Well, in continuation with the elementary concept of differentiation and integration in describing motion of a particle, we'll pick up some simple examples of differentiation first. So here let us find the differential coefficient of a function y is equal to pi. Y is equal to pi. So pi is a constant, you know, pi is a constant. So therefore differentiation of any constant is 0 as we have seen. So therefore d by dx of c, that is d pi by dx, is equal to 0. So therefore differentiation of a constant being 0, so derivative of pi equal to 0. Similarly, you can pick up any differentiations of any constant, that is any de by d equal to 0, like that. Now to pick up the second one, that is d by dx of square root of x. Now here our y being equal to, so we can write it as like this, that will d by dx of x to the power half. Here n is equal to half. So therefore we can apply very well the formula, that is d by dx of x to the power n, which is nothing but n into x to the power n minus 1, as we have given the formulas earlier. So therefore here I'll apply my n equal to half. So therefore here it is n into a to the power n minus 1. Here n is half, so half minus 1. So therefore you will get 2x square root, like that one. And the third one is here differentiation of y is equal to sine x cube. So here we can do one thing, that is we can pick up it here, that is C, that is y is equal to sine of x cube. We can let it, that is x cube is equal to n, some another functions. So x cube you have taken as the parameter, another parameter n. So therefore we can write it, that is 3x square is equal to 3x square dx is equal to dm, like that. So we can substitute here in place this one, I can write it as sine m, isn't it? So therefore our dy by dx can be written as d by dm of sine m into dm by dx. We have taken the differential coefficient with respect to m and also again multiplied that one. So therefore this is in chain rule, we can apply this one. What is this one? This is nothing but cosine of m, that is sin m derivative becomes cosine m, and here dm by dx is what? That is from this one we can get, that is dm by dx is nothing but, that is 3x square. So here we substitute 3x square. So answer, this is 3x square cosine, and in place of cosine we can replace, that is cos of x cube. We have taken x cube. Similarly, we can pick up any other functions like the second one. In the second one we can pick, that is if s is a function such that it is given as ut plus half at square for a body in motion, then we need to find out the ds by dt and ds by dt at some instant of time when t equal to 0, and d square s by dt square. These values we can find out, and we can check it that ds by dt is nothing but the velocity, and ds by dt at t equal to 0 is nothing but the initial velocity, I mean with which the body starts the motion, and the d square s by dt square is accelerations. Now let us see, let us check it. That is, if our function s is given by number 2, if s is given by ut plus half at square, then ds by dt, how we write? D by dt, in place of s I can write down ut plus half at square. So therefore we can make it two separate functions, that is d by dt of ut first, and again d by dt of half at square. Recalling the formula, that is d by dt of u plus v plus omega, like that we have separated it. Now here u being independent of time, u doesn't have any variations with respect to time, so I take it outside. So u into dt by dt being 1, and the here a being constant, half a being constant, I take it outside, so d by dt of t square. Now here this one being 1, so I have u plus here half of a, and here I can apply n into a to the power n minus 1, so therefore it becomes 2t. So I get the answer as u plus at. And what is this ds by dt in physics? This is u, so this is velocity term we say. So v equal to u plus at, which is the one of the kinematical equations. You can start from s equal to ut plus half at square and get v equal to u plus at. This is how we have get the first part of the second problem, and similarly you can apply, that is ds by dt at t equal to 0. When t equal to 0, in this expression the second term vanishes, so therefore I write it vu. So to distinguish this one, you can write often, very often, as u0, but here we take it as u as such, so therefore it becomes v or this is the initial velocity, you can write it is the initial velocity. And the third one is that this one, d square s by dt square, you can check it as, or you can differentiate this term again, that is d by dt of ds by dt, and ds by dt already we have got to be equal to here, that is v equal to u plus at, so I can substitute here d by dt of u plus at, u plus at, and how much it will give? That is v being constant, I mean u being constant, this is u being constant, it is 0, so therefore the second term in a being constant outside, so dt by dt 1, so therefore this is nothing but the acceleration term. So d square s by dt square is nothing but the acceleration term. Now you can see that this is how you get the various physical parameters in physics of motion by applying the differential coefficients. Similarly, the third example also we can try it quickly. So let us see. The third one is that, what is this one is saying? That find the acceleration of the particle moving along x-axis, which is describing the motion as xt is equal to a plus bt plus at square with respect to time, where t is the time and abc are the respective constants. So if that is the case, let us see how to find out the accelerations. For the accelerations, as we know, that is our function is what? Xt is equal to a plus bt plus ct square, and our acceleration term is nothing but that is d square x by dt. Here I have written x is a function of time, that is obviously x is a function of time. So here how can we do that one? That is, we can write it as a d by dt of dx by dt. That means we'll have to first differentiate this one. If you differentiate this one, what is the value we are getting? That is dx by dt. How much we are getting? D by dx of d by dt of x being a plus bt plus ct square. You are getting here a being constant, the first term dA by dt, this is giving 0, and the second b dt by dt, and the third one is c into d by dt of t square. So therefore you are getting, that is this being 1, so you are getting b plus c into derivative of t square is how much? 2t. So therefore you are getting b plus 2y is ct. Now you can substitute this one here, that is d by dt of this value, you can substitute it dx by dt to be equal to b plus 2 ct. So how much you are getting then? That is dB by dt, this is being constant, you set it to 0, and the 2c being constant outside, now dt by dt. So therefore the acceleration term you are getting 2c. This is how you can apply in various cases of the particle under motions to find out the velocities, accelerations and various parameters as we have described. Now similarly we can also apply to some simple examples of integrations in my next class. Thank you.